Welcome to the session on creating an expense management app using iProof platform. The requirements for this app is screened for your reference. In this session, we will configure various widgets of the platform to create the expense management app as expected. Let us begin. Log on to iProof platform with admin user credentials. Check out the Process Engine feature on the dashboard. Use Package Console to create a new package. Package creation marks the logical split or separation of various business process solutions that could be built on the platform. To create a package, simply click on the Add Package icon and provide valid and meaningful name, description, and save it. The next step is to create a process within the package created. To do this, click on the plus symbol against the package created and choose the process. Give a name, ID, and description and save it. Once the process is created, click on the process name on the package console to enter the Design Studio. We shall now begin to configure the expense management app. We will begin our configurations with the conceptual model, where the data items required by the app shall be created. Since the expected outcome has a grid, an expense details grid element is added. All the other data elements such as city, location, location manager, etc. which are found in the requirements will be represented as columns in the grid. We can create these elements one by one, or to save time we could use the editor to post the data item names with requisite syntax and create them in one shot. Once the elements are added, switch on the settings on the toolbar. Click on the setting icon against the grid to set the grid type to form grid. This is for making the grid with stacked and merged cells and also make it editable. We now move on to create the user interface design for the app using Smart UI. Add the expense detail data element on the Smart UI canvas under the main container. Now choose the grid from the list of container controls and design the form grid as shown. All the required data elements within the grid are added to the form grid, and the required UI properties for these data elements are set to achieve the look and feel of the grid shown in the requirements. After designing the form grid, get back to the root element and save the changes. Now select the expense detail grid header on the layout tree to perform merge. In the merge pop-up, we can provide any desired HTML template for the UI, provide the column names to be merged before saving. This template and column merge would achieve the desired grid style with stacked and merged cells. Just to ensure the UI design, one can publish and preview the app. Next, we would focus on data persistence. We will first create a connection variable to connect an existing database where the data received would be persisted. We use Connection Manager to create the connection between the app and the database through a connection variable. To create a connection variable, choose the type of database and click on Add Connection. Then provide an appropriate connection name, DB name, IP address, username and password, and description if any. We can test if the connection is successful or not before saving it. Once the connection variable is created, the next step is to create domain data maps, where we create data table representation within the app. We can create any number of domain data maps which are data table representatives that could eventually be used by the app in the making. Here we are trying to obtain a domain data map of an expense details data table from the sample database, which is connected through the connection variable we have just created. This is the data table which will eventually persist the expense details app data. Next will be mapping the column names from the backend data table to the data elements in the process app. This is done using the repository mapping in Business Logic. In repository mapping, first a new repository is created and it is mapped onto one of the existing domain data maps. Then, within this repository, data elements are matched against the data columns. It is important to note that the data type of the data element and the column that is matched must be of the same type. After setting the column maps with the intended data elements, we can persist the data in the requested data table by creating appropriate actions in Business Logic. Actions in Business Logic defines the intelligent space of the process app being built. There are a number of possible actions that can be configured to achieve even the most complex operations with just a few clicks. Here we are defining an action CRUD, which is create, update or delete records in the expense details table by merely selecting the appropriate built-in functional snippets. A sample for defining actions to perform calculations is also shown for your reference. Once the required actions such as the CRUD and others are configured in Business Logic, It needs to be associated with appropriate triggers. Here, triggers are events that are raised within the app. Associating these actions to these triggers will help the actions to be invoked when an appropriate event happens. We can even define the actions that can help set the properties of the data elements or UI elements during runtime. Here is an example of how to set properties of such elements using actions. Also, we have a provision to set GUID to an identifier column in repository mapping. This is extremely helpful if the identifier column has to be unique and has to be auto-generated within the app. Having associated all the actions against appropriate triggers, the app is now ready for publishing. After publishing the app, it could be launched from the package console as shown. Now the app is ready and running. Thank you and have a great day.